Pressure safety valves are considered as an essential component in the plant. So, if the system is considering a relief scenario where a PSV shall open, the system cannot operate if the PSV is out of service. So, does this mean that it is better to add a spare PSV? This mainly depends on the relief scenario on which this PSV is sized. If the PSV was sized based on scenarios that are related to an operational issue, such as control valve failure, for example, or cooling failure or blockage, these issues may be handled quickly. So in this case, we shall need a spare PSV so that we can restore the system back to operation as soon as possible. However, in other cases, we may not need PSV sparing. For example, if the scenario was based on fire case only, then for sure we cannot restore the system to operation until extinguishing the fire and making sure that there has been no damage in any of the system components. Or if the PSV is protecting the piping from thermal expansion. The thermal expansion scenario won't happen unless the pipe is already out of service. So why would we need a spare PSV in this case? There shall be no need, as line itself is out of service, so we don't need to restore it back. However, we won't add a spare if the PSV is expected to protect the system from fire or thermal expansion only. If there are other associated scenarios, for example, a PSV protecting the vessel can be sized for both blockage and failure scenarios, and it is considering the highest relief load among them. Maybe the blockage is controlling, but still there is a fire scenario. So in this case, fire scenario is the controlling on which the PSV is sized. However, in case of blockage, we shall still need spare PSV. So in this case, we shall consider a spare PSV. Now, let's talk about the configuration on which we shall apply the PSV isolation. If we have a single PSV, then in this case, we can use a removable spool without any valves on the PSV inlet. The vessel would already be out of service as it cannot work with a PSV. Or we can use just a valve with a bleed to isolate the PSV. For the PSV outlet, if it is venting to the atmosphere, then there shall be no need for the valve on the PSV outlet line because it's already venting to atmosphere and there is no pressurized system downstream like the flare. However, if the PSV is connected to the flare system, then we should isolate it from the flare system. So here we shall add a valve with a bleed on the PSV outlet line. It should be a full bore valve to ensure the minimum pressure drop when the safety opens, and hence we can make the relief process faster and easier and ensure the equipment maximum protection from overpressure. In addition, the isolation valve should be locked in the open position to avoid closing it by mistake. This can lead to a catastrophe, as this can cause the vessel to be subject to overpressure. Finally, before we empty the vessel, we need to depressurize it. That's why a vent connection to the flare is usually considered. This is shown as a bypass to the PSVs. This bypass is isolated using a gate or a ball valve. The vent here is done manually through a globe valve to adjust its opening. Here we should consider a distance of 600 millimeters to the isolation valve to avoid icing of the valve stem in case the temperature suddenly drops due to depressurization. The concept of depressurization needs a separate video and we shall talk about it later in the course. However, this is a different subject. Needless to say, the depressurization can be automatic and triggered from a shutdown signal to open the blowdown valve, or it can be manual as in our case here. Here we are just showing the use of PSV bypass line to depressurize the vessel. If there is already a blowdown connection, we may not need this manual one. However, this is a different story. Needless to say that we shall consider the main PSV isolation valves as locked open and full bore, while the bypass valve shall be locked in the closed position. If any PSV isolation is closed by mistake, the PSV won't perform its job, and the vessel won't be protected, which is a severe safety issue. And if the bypass vent valve were open by mistake, the vessel would lose its pressure, which can lead to process shutdown. Sometimes we can have more than one PSV. This is the case when we are expecting a very large relief load that one PSV will not be enough to handle. This is not a spare PSV in this case, both are in service. Here we shall need an isolation valve with a bleed on each PSV inlet, and of course we shall need a valve on the PSV outlet, and the isolation valves are locked open and full bore. If this is a spare PSV, the inlet valve would be locked in the closed position for the non-running PSV, and the outlet valve shall still be locked in the open position. We also need to ensure that at least one valve is open. So the isolation valve on the first PSV cannot be closed unless the valve on the second PSV is open. This can be done using a mechanical interlock, which ensures that if the operator closes the valve on one PSV, the other valve shall automatically open to ensure that there is at least one PSV in service.